Hi, welcome back. So we're going to do a couple of examples, and we're going to stick with tangent right now. So what we're going to do is we're going to actually write the formula for the function that is graphed. And you know it's tangent in part because tangent is the only graph we know right now, but also because it matches that elongated S shape that we saw is characteristic of tangent. So we know we're going to be writing something that looks like f of x equals something times the tangent of something times x, maybe plus c. Now, if we look at our curve, we can see that our center line is along the x-axis. So we know that c equals 0. Now, we remember that our observed period is equal to our natural period divided by that internal multiplier. If we look at those x-intercepts that I just graphed, and one of the things about tangent is that it goes through an x-intercept once each period. Remember, sine and cosine each have 2 x-intercepts per period. Tangent only has 1. And so we can see that the distance between those x-intercepts is 2 pi. Right? Or we could have done this a little differently. We could have looked at this point here, where x equals pi over 2, and marked where that is, and where it repeats itself, and we still would have seen that that distance is 2 pi. Which means that our observed period is equal to pi divided by our internal multiplier. And we can do a little bit of work, and we get to b equals 1/2. Okay, so what I have now is that f of x equals something times the tangent of x over 2. Let's look now at this point that I marked, this guy right here. That is the point pi over 2 comma 3. So that tells me that 3 equals a times the tangent of 1/2 of pi over 2. Well, 1/2 of pi over 2 is pi over 4. So that means that 3 is equal to a times the tangent of pi over 4. And we remember that pi over 4 is 1, which means then that 3 equals a. So our final result is that this function is 3 times the tangent of x over 2. Okay, let's try another one. Same thing, but this time we're looking at this curve. All right, so what do we know? Well, the first thing we notice is we can again count our x-intercepts, and we see that we have a distance of 5. We could also look at these points here, and this is the point 1, 1, and this is the point 5. Sorry. That is not the point 1, 1, and that's, we can live with that though. That is the point 1/2, 1, and this is the point 5.5, 1. And so again, we see that those repeating points are separated by a distance of 5. So the period of this function is 5. And the midline of this function is the x-axis. And we've got a known point. We know that it goes through the point 0.51. Okay, so we've got enough here. We know it's a tangent because it looks like a tangent, right? So I'm going to start with my basic tangent. We already know that the midline is at the x-axis, so c equals 0. We know that the period is 5, and that is pi over b. So b then is pi over 5, right? So now I know that my function is something times the tangent of pi over 5 times x. And to get to that something, we're going to use that known point. So we know that 1 equals, well, that's not a very good known point. Let's see. Well, it'll do. Okay. Something times the tangent of pi over 5 times 1/2. Yeah? Okay. Now, here's what that means is that pi over 10. Now, if you don't like that point, and I kind of don't like that point, but that's okay. You could use another point like this one, but that's not going to be much better. So we're going to stick with this. And the reason I don't like it is because pi over 10 is not a special known unit circle value. But that doesn't matter because I can come to Desmos and find the tangent of pi over 10. And it gives me 0.3249. So that means 1 equals a times 0.3249, which means that a is 1 over that. All right. So I'm actually going to do this. I'm going to take 1 divided by the tangent of pi over 10, and I get 3.077. So my function then is 3.077 times the tangent of pi over 5 times x. All right, so that's the basic method for writing the equations of tangent functions that are shown. Find your period, pick a known point, use that to find your external multiplier. All right, I'll come back and we'll talk about secant and cosecant.